Now we will train our network. Let's initialize our neural network model. After that, we will try to run it for 300 epochs with a learning rate of 0.05, and we will also keep track of the history of our losses, the history of our train accuracies, and history of our test accuracies. And then for epoch, let's scroll it down a bit. For epoch in range, you can also start this loop by 0 so that you don't have to add +1 in the end. Then loss will be equal to model dot train step, and then x train, then y train, then learning rate, and then the train accuracy will be equal to accuracy of the model, and then x train, y train. Yeah, and for the test accuracy, it will be equal to accuracy model, and then x test and phi test. And then we will just append all this to the history of our losses. History, and then train accuracy dot append trained accuracy history test ACC, and then we will just print everything. Print times 10, and then print epochs, just giving a bit beautiful spaces here, and we will also add epoch here. So this will be an f string epoch, and then the number of epoch 03D, and then times 10. Yeah, and then after this we will print the loss to 4 decimal places, which is enough for our purpose. And then train accuracy, which will be train ACC 0.4f. And finally we will print the test accuracy, which will be test ACC to the 4 decimal places, and just run it. As you can see, we hit an error, and what this says is there is a value error, which is operands could not be broadcast together with shapes 120 and 123. So after figuring out a bit, I have found that the neural network that we have created wants one hot encoded values. That means it wants 3 columns per input value of y. But what we have done is, since the inputs were given as the pure numbers, we didn't encode it to the one hot format. So we have to rectify it. Let's add a cell here, and then we will be writing num classes equal to length of np dot unique y. So what this will do is, this will give us the number of unique values present in the y, and then we will initialize y equal to np.i. So this is a replacement for the one hot encoder, so that you don't have to import it from the scikit-learn library. then y. After this, what we have to do is we also need to change this. So we will change this to capital Y because now we are using capital Y, or just what we can do is we can change it to Y. Now this should work. Let's run this cell. Then at the end, let's run it. Let's restart and run everything. Restart and run. Also, and now I have figured it out that there is a small correction in the dense layer section. So let's go back to the dense layer and let's remove this cell, because then now our dx is a local variable and not the self part. So let's run everything. Let's see what's the error now. Yeah, so history test ACC is not defined. History test. Oh yeah, the spelling error. And now you can see our neural network is working perfectly fine. Let's see. And after that, we will plot the accuracy graph. Or let's plot the training curves first. Also, we saw that our accuracies were a bit low in the range of 50s and 40s. So what we can do is just go to the dense section, and here there was division by m like this. So since we are not using batch wise conversions, or we are not using batches for training, so it's better to remove like this so that our accuracies are accurate. I mean, our model is accurate, but when it shows the accuracies, it will give us the wrong answers. And now when we run that code block, it will give us the proper accuracies.